Hey everyone, welcome. Thank you all so much for being here. We're going to be talking about design best practices for display AI glasses. And I'm Yasmine Evjen, and I am a product manager on the Android XR developer experience team. So today we released the Developer Preview 3 for the Android XR SDK. And with its release, we are opening augmented experiences development for AI glasses and display AI glasses. AI glasses are lightweight and portable for all-day wear. With built-in speakers, a camera, and a microphone, developers are able to build intelligent and hands-free augmented experiences. With the addition of a small display, you can privately see information, harmonizing with audio output. These personal devices allow you to build experiences that enhance a user's focus and presence in the real world. Our Jetpack XR SDK enables mobile app developers to extend their app into this new form factor. With the Jetpack projected library, you can enhance your existing mobile app to utilize glasses hardware, like the camera for first-person point of view. And with AR Core for Jetpack XR, you can use perception capabilities for tilt-down gestures to show additional content, and geospatial visual positioning service for more accurate navigation. And if you're already developing for Android, you're ready to develop for glasses. Notifications will display on AI glasses, showing ongoing timely live updates that are in progress. Our activity model builds on the same foundation of Android app development. Using the existing Android Activity Framework component, you can create dedicated activity that runs within your phone's existing app. To learn how to develop for AI glasses, please check out Getting Started Developing on AI Glasses talk, where Kabir, Tram, and Batul get into the developer details. But just because display AI glasses use the same Android development process, that doesn't mean you should port your existing mobile app without any modifications. Bright field surfaces can cause discomfort for users, and unoptimized typography can be difficult to read. We recommend creating differentiated AI glasses experiences for this new form factor. We have some great examples here that our wonderful design team put together. And as you can see, it really builds on enhancing the world around the user, not taking over. And I know what you're thinking, but how do I build all this beautiful, wonderful UI that's so pretty? Well, I'm here to tell you, to help you build for display AI glasses, we are releasing Jetpack Compose Glimmer, our new design language and UI toolkit for augmented experiences. Jetpack Compose Glimmer is a demonstration of design best practices for beautiful optical see-through augmented experiences with UI components optimized for glasses input modality and styling requirements. With the device that is so closely integrated with your day-to-day, our research and design team identified key principles for creating UI that is respectful, graceful, and comfortable. Display AI glasses are designed for all-day wear, providing convenient hands-free access to information. Our primary goal is to respect the wearer's focus on the real world by prioritizing physical surroundings over the user interface. You'll want to present information concisely and adaptively, considering proper size, readability, and time on screen at each stage of the wearer's journey. Prioritize essential information and layouts, reducing actions and visual elements to maintain user focus. Manage content density to respect limited field of view and prevent cognitive overload, ensuring comfortable readability. You'll want to craft user experiences for glasses that prioritize glanceable enhancing UI and temporary elements, recognizing the fleeting nature of interactions on such devices. You want to guide the wearer's attention with smooth, deliberate motion that avoids distraction, ensuring movements are purposeful and fluid, boasting focus and offering direction without overwhelming the user experience. Sensory and cognitive comfort are essential to crafting user-centric glasses experiences, minimizing the mental effort required to gain helpful and timely information. Take, for example, Google Maps, which provides helpful information like your next turn, and with a simple tilt-down gesture, head gesture, you can see the map. This allows you to keep the user focused on the world around them while also giving additional helpful information with a simple head gesture. With these principles, Jetpack Compose Glimmer UI is designed for clarity, legibility, and minimal distraction. Please join me in welcoming David Allin to share how Glimmer encompasses these principles with simplified styling, differentiated focus, and optimized elevation. Thank you.
Thank you, Yasmine. I'm David Allin. I lead visual design for AI classes. Today I'm going to tell you a little bit about why we created Jetpack Compose Glimmer and what are some things you need to think about to build beautiful, transparent experiences. Glimmer is a design language of light and transparency. You'll see glanceable typography, fluid motion, and legible color. But I think it's really important to remember that Glimmer is not just a theme. Every element in the interface is a result of solving for constraints that are very specific to glasses. These constraints also gave us the opportunity to find what a beautiful experience should look like on AI glasses. The biggest constraint, and the one that defines everything else, is the display, and how that display is placed over the real world. The interface will always be displayed within someone's field of view, perceived at about 1 meter away. And that person could be hiking, they could be watching a sunset, they could be having a conversation with someone, they could be having a meal with friends. The point is, whether the display is on or not, their attention is likely on the world, not on the display. And if you bring your attention to me, for those of you watching and in this room, I have a brief exercise. If you take your hand and you put it at arm's length, about eye level away, and look at the tip of your fingers, just notice how the space behind your hand is out of focus. It is blurry. Notice that your periphery is out of focus. Your focus is on your hand. And this is about as far away as the glasses display is perceived. It's about 1 meter, more or less. And also, as you bring your attention back to me, notice the small amount of time that it takes to shift your focus. The science of seeing and the human factors of attention and focus lie at the heart of every decision that we've made when designing Glimmer. And it's led to 4 specific challenges that we had to solve that I would love to share with you. First, transparency. Glasses use an additive transparent display. What does that mean? It means it can only add light, and it cannot create black. It can't make the world darker. What you see in design tools is not how it will appear on glasses. This led us to ask, how do you create surfaces? How do you create depth and hierarchy without the use of shadows? In the design system, to solve this, we reconsidered the role of black. First, our surfaces use black not as a color, but to give the ability to include other content behind them and give your content a legible container. Second, we have a new depth system that uses rich, dark shadows to create a sense of elevation and depth by gracefully occluding content behind it. We think this is quite clever. Second, typography. Unlike phones that you can bring in for a closer look, glasses are fixed about 1 meter away. That's how far typography is perceived, similar to your hand from before. This meant we had to take what we've learned about typography from spatial experiences and optimize it and apply it to glasses. So what does that mean? In this case, text is measured in terms of degrees. For example, how many degrees a letter takes up in your field of vision. We worked closely with our vision science team to establish a minimum of around 0.6 degrees for text. Our typography styles are well above that, terming glanceable in the most number of environments. It's important to remember that these values translate to specific pixel values based off of hardware specifications. We're also really excited to be using Google Sans Flex in a unique way by optimizing the font's optical size, using the optical size axis. This means letters are more legible. How so? For example, A's and E's have larger counters and longer arms. J's and I's dots are larger and further away. Optical size also adds optimized letter spacing without having to specify it separately in code. I'm also really happy to share that Google Sans Flex is now open source so that anyone can use the same technology we do to design beautiful experiences for glasses. Color, third challenge. Color behaves entirely different on transparent displays than typical ones. First, our interface is neutral by default. This is our primary strategy for harmonizing with the diverse colors of the real world. This means surfaces are always dark, and the content itself is always bright. This high contrast default is why our foundation for legibility in most environments and avoids distracting light bleeds like halation. We make this decision because the environment around us is constantly changing in brightness as well as color, which also changes all of our assumptions about visual contrast. The perceived brightness of content is an equation that solves for additive contrast ratio. This equation just takes into account the brightness of the environment as well as the brightness of the display. Practically, what this means is that the same UI against a bright sky appears entirely different than one in a dark room. This equation is also why highly saturated colors like those that you use on a typical display, like on a phone, just don't work. Those darker colors essentially disappear against the world and become unreadable. Because of this, Glimmer provides specific guidance for a desaturated but still colorful palette. We use colors that are closer to white to maintain contrast. This ensures the UI remains stable and legible in most environments. To test the colors in your UI, we've updated our Compose Preview and XR emulator in Android Studio to help you visualize your UI on display AI glasses. Fourth and finally, motion. On a heads-up display, motion input should feel graceful. It needs to guide attention without being distracting. It needs to feel light while also feeling expressive. It also needs to be responsive. Our lists and stacks are a great example of how all of this comes together. Scrims make moving through lists feel ephemeral, while an item in a stack gently disappears. These are also a great example of our focus styling. It provides a distinct signifier for focus, as well as features a unique highlight effect that speaks to Glimmer's light-based language. With that, I'd like to invite Adhithya on stage to talk about how we built all of this into our components.
Thank you, David Allin. My name is Adhithya, and I lead design for Android XR developer experiences. We've seen the why behind Jetpack Compose Glimmer. Let's get practical and look at the how. It's fascinating to see the science behind the design choices. But as developers, hearing about additive color physics and the degrees of visual field might sound a little daunting. Well, here's the good news. We've handled those constraints for you in how we built Jetpack Compose Glimmer. We built a comprehensive set of out-of-the-box components designed specifically for glasses UI. These include your foundational building blocks, like text, icons, and buttons, but also specialized components for glanceable UI, like lists, stacks, and cards. When building this library, we optimized for two critical hardware realities: the touchpad input and the glasses display. Let's start with the input. Every component we've designed is pre-wired for glasses-specific gestures, like swiping and tapping on the touchpad. This means your apps work seamlessly across different hardware configurations and manufacturers without you needing to write custom gesture logic. Second, the display. Remember the optical constraints we saw earlier? Glimmer components automatically apply the correct legible typography, additive safe colors, and a depth system that just works. So let's dive into our primitives. It all starts with Glimmer theme. Glimmer theme allows you to control fundamental aspects of your UI, like colors, typography, shapes, depth levels, and icon sizes. You can use the default Glimmer theme right out of the box. It adheres to Glasses' strict legibility standards, and be rest assured it's the fastest way to ensure your app looks strictly wonderful on Glasses. Starting with colors. You just call glimmertheme.colors. This immediately gives you access to the correct high contrast variations you need for Glasses UI without any guesswork. The same out-of-the-box ease extends to shapes, icon sizes, and depth levels. Just look at these depth effects. You don't need any complex custom code, And in this specific case for depth, you just call the predefined depth levels, and the beautiful shadows that you see here are rendered automatically using our latest drop shadow APIs. Now let's talk about focus. With a touchpad input, we don't have the luxury of direct touch. We need to tell the user what they're interacting with on the touchpad. We designed a unified 3-state focus mechanism across all Glimmer components: default, focused, and pressed. The focus mechanism is handled via a 2-layer approach. Layer 1, which is your brand color or out-of-the-box theme that comes with Glimmer, and layer 2 is a consistent closed token that handles the gradient border highlights. And combining these 2 layers produces a focus highlight effect. The focus system works across all components on Glimmer without having to write a single line of additional code. But if you do want to inject your own identity into the experience, Glimmer is not rigid. It provides a way for you to customize the focus highlights in addition to other themable attributes such as type and color. This gives you control over your app's aesthetic, so you can define the Glimmer theme that works for your brand. We've covered the primitives, but you don't build apps just with primitives. You build them with components. All of the intelligent defaults that we just discussed are baked right into the initial set of Glimmer components that are available today. Now let's see them in action. Starting with the button. Glimmer's button is automatically styled by the theme, but it really shines in how it handles input. When you use a Glimmer button, you get clear outline-based visual feedback that respects the user's field of view. You simply call button. The theme handles the color, shape, typography, and focus state outline automatically. You can also choose from standard or large sizes of buttons and easily add leading or trailing icons as well. Next, let's look at the card component. This is your most essential component for organizing and presenting related content on Glasses UI. A Glimmer card is highly adaptable. It's designed to be the primary unit for displaying content. It's focusable, clickable, and supports a wide range of layouts through predefined slots. Let's look at the code. For a simple implementation, you just call the card composable and drop your text inside. The input handling, styling, and focus come for free. But you can also leverage more complex slot APIs for richer layouts. Here, we have a header slot for images, title and subtitle fields, leading and trailing icons, and even an action slot for button. Notice how the button automatically aligns itself to fit perfectly within the card's layout. All of this is just out-of-the-box magic without having to write any custom layout logic. Now, what about scrollable content? For that, we have the vertical list. Vertical list efficiently renders content that exceeds the viewport size by optimizing the visible content and ensuring smooth scrolling for the overflow. This is critical when that viewport is floating right in front of your eyes. It also features built-in support for touchpad interactions. You can see here that the traversal logic is already handled for you. As we move through the items, the component applies those pre-baked highlight animations we saw earlier, making the scrolling experience feel responsive, grounded, and alive. Here's what it looks like in code. We call the vertical list composable, which acts as the container and handles the graceful scrim effect at the edges when scrolling. Inside, we have the list item. The component handles the scrolling mechanics, the focus highlights, and the performant rendering for you. Now let's talk about stacks. Stacks allow you to layer content effectively letting the user focus on one important piece of information at a time. These use our specialized step system to occlude content gracefully. When you push a new item into a stack, notice how Glimmer orchestrates the transition. It just doesn't cut to the next frame. It uses the depth system we discussed to gently recede the old content while the new layer flows in. This creates a sense of spatial movement that feels completely natural and helps users maintain context. And here, you can see a sample implementation of a vertical stack, where the depth effects are automatically applied and the stack neatly laid out for you that's optimized for display glasses. We've covered the basics, from the smart defaults of Glimmer theme to powerful components like cards, lists, and stacks. We build tools for you so you don't have to worry about the physics of light. You can just focus on building incredible experiences. To share some final thoughts, please join me in welcoming Yasmine back.
So today we dove deep into the principles of Jetpack Compose Glimmer, what went behind designing a system for display AI glasses, and highlighted a few of the UI building blocks that are available for you to build augmented experiences. To help you get started, we're releasing design guidelines and developer documentation on developer.android.com/XR to build beautiful augmented glasses UI experiences. For all the designers out there who are interested in designing for this new platform, we have a Figma design kit that will help you get started to envision your app on glasses. And for all the developers who are keen to understand how the Jetpack Compose Glimmer library works, we have a sample app and Android Studio project template to help you get started. We cannot wait to see what you build with Jetpack Compose Glimmer, and thank you.